So I can't have you leaving my class without knowing why boats float and planes fly. This lecture is about fluids, which include both liquids and gases, and we're going to learn about density, pressure, Archimedes' principle, which relates to buoyancy, Bernoulli's principle, and some other interesting stuff along the way. So have you ever wondered how planes fly? They weigh so much, and they stay up in the air, and air is so light. How does that work? Or how those huge barges that weigh so much, they carry those huge box cars, how are they floating in water? I mean, the barges themselves are made of steel oftentimes. They're just carrying immense weight. So what the physics is going on here? We'll start with density. Density applies to more than just fluids, but it's especially relevant when we start talking about buoyancy. So density is mass per unit volume, and we use the Greek letter rho to denote it. So mass per unit volume. And we talked about the units for it before, but that would just be kilograms mass per cubic meters. Yeah. So how much mass is stuffed into how much volume? Iron is denser than water, water denser than air. If you place a solid block of iron on a layer of water, it sinks, but if you place a solid block of air or wood or something less dense on water, then it floats. There are some materials that are incredibly dense. The densest material on Earth is the metal called osmium, with a density of 22,500 kilograms per meter cubed. One standard brick of osmium weighs 24 kilograms. That's about 53 pounds. And by the way, it would cost over $300,000. This pales in comparison with the density of some astronomical objects, though, like neutron stars with densities in the range of 10 to the 18th kilogram per cubic meter, and the singularity point at the center of a black hole, which can be thought of as having infinite density, but we'll pull it back a little bit.